All right, our last special parallelogram that we're going to talk about is a square. So you guys already know some things about squares. You know it has four congruent sides. You know it has right angles. But we're going to talk about it in more detail. So if a parallelogram is a square, then the properties of both a rectangle and a rhombus apply. Okay, so if you have a square, then what are some of those properties that would apply? We know that the diagonals are perpendicular bisectors. We know that the diagonals are congruent. So diagonals are perpendicular bisectors. That comes from a rhombus. So if it's true for a rhombus, it's also true for a square. The diagonals are congruent. That's true in a rectangle. So if it's true for a rectangle, it's true for a square. And the diagonals are angle bisectors. That is true for a rhombus, which means it will be true for a square. So one thing to note, you know, a square is a very specialized parallelogram. So a square is also a parallelogram. A square is a rhombus, and a square is a rectangle. It's probably the most specialized polygon that we have, because not only does it fit all of your properties of these, I think as you get more specific, we get down to a rhombus, and then you take a rhombus and you make all your angles, right angles, now you've got a square. So what about the converses of these statements? A converse is where we switch the order. So is a rectangle a square? Not always. Is a rhombus a square? Not always. Is a parallelogram a square? Not always. Most of the time, in fact, it's probably not. But if you get very specific, a square is also a parallelogram, a square is also a rhombus, a square is also a rectangle. Okay, so we've got a square. Figure WXYZ is a square. If WY plus XZ equals 92, so let's just find WY is one diagonal, plus XZ, the other diagonal, is 92. What is the area of triangle WPZ? So WPZ is this triangle. We can see it's shaded for us. Mine is blue, yours is probably gray. All right, so we have a square, so what are some things that we know? We know that the diagonals are congruent. So if the two diagonals that are the same length add up to 92, then let's just take that 92 and cut it in half, and we'll find that WY must be a 46 and XZ must also be 46. All right, well, we can keep going. We also know that the diagonals bisect each other. So if we know that each diagonal is 46 units long, we can cut that in half because it is going to be bisected. And we know that WP is equal to 23. Also, PY is 23. Or here, we're going to bisect those. Let's just show those congruencies. WP is 23, and then ZP is also 23. I'm focusing on these two sides because those are the two sides of, or those are two sides of the triangle we are asked to find the area of. Okay, well, what else do we know? We also know that in a square, the diagonals are perpendicular. That means that we have right angles. So I'm going to go ahead and put a right angle in because they're perpendicular. So now triangle WPZ, the one we're trying to find the area of, now we know it's a right triangle. All right, so to find the area of a triangle, area is equal to 1/2 base times height. You could do base times height divided by 2. And when you have a right triangle, I'm going to go ahead and redraw the triangle off to the side over here. Here's that right angle. We know each side is 23. When you're finding area, the base and the height of a right triangle are these two legs that form the right angle. This is the base of 23. This is the height of 23. So the fact that this is a right triangle is very helpful because now we know what our base and our height is to plug into our area formula. So 1/2, our base is 23 times our height of 23. When we multiply those three together, we get 264.5. We don't have a unit of measure, so we'll just say units squared because that is an area measurement. All right. Just some quick questions here to run through about a square. We've got WXYZ as a square, so why don't we fill in some things we know. ZP is 7. We know that PX will be 7. Diagonals are congruent and they bisect each other, so WP is 7 and PY is 7. We also know that the angles are right angles and that those diagonals bisect each angle. So that gives us 45 degrees at each angle, two 45-degree angles. So if this is a 90-degree angle because it's a square, this diagonal right here coming in bisects that, cuts the 90 degrees in half, so you have 45 and 45. If you go around the whole square, you have where those diagonals are coming in, it creates two 45-degree angles, 45, 45, 45, 45. All right, well, let's see if we can answer some questions. Find the measure of angle YPZ. So from Y to P to Z, oh, it's the one thing we didn't mark. So YP to Z, so we're at P. Remember your diagonals are also perpendicular. So we have right angles there where they meet. So that gives us a 90-degree angle. Part B, find the measure of angle XWP. So W is the vertex. XWP, go back to W. We just identified that as 45 degrees, so we already figured that one out. Find XZ. So XZ is this whole diagonal. We have 7 and 7, so we'll add those together to get a total of 14 units for XZ. And then the other one is WY. Well, we know diagonals are congruent, so we already know it's going to be 14. We also could go ahead and add those 7s together and get 14 that way.